Hello and welcome back to another episode. So today we're going to be going over the Pythagorean identities here. And so this is a trig topic that I feel like a lot of people, this is kind of like where a lot of people start having trouble with trigonometry, is this right here. And obviously identities. I'm just going to write these. So there's a couple of different ways of looking at these, and I've discovered this one, which is probably the best way of doing it. Going back through my calculus courses, I'd always try to find little tips and tricks of how to remember the trigonometry from obviously my trig class, and I think doing it this way is probably the easiest way to remember all of it. And so we're going to start with our equation of a circle, which for those of you who remember from algebra is going to be x squared plus y squared is equal to r squared, where r is going to be the radius of your circle. So we're going to have something like actually a circle. And so this right here is your radius. And what we're going to do is we're going to set our radius to 1. So r is going to equal 1, which in turn means r squared is going to equal 1. And so now we're going to rewrite our equation here simply as x squared plus y squared is equal to 1. And so this kind of is where a lot of it starts, right? Where we can start using this for our trig identities. And for those of you who don't know, this is going to be your unit circle in trigonometry. It's really important. And so in trig, we let cosine of theta be equal to x over r. But when r equals 1, that just means that cosine of theta is going to be equal to x. And then the same thing here with sine. So it's going to be y over r, but when r is equal to 1, sine is going to be simply equal to y. And now we can actually plug these in. But before we do that, let's go ahead and look at some of the other identities as well. And so we see like our reciprocal identities. So cosine of theta is going to be equal to 1 over secant of theta, or conversely, secant of theta is equal to 1 over cosine of theta. And then same thing here with sine, right? So sine of theta is equal to 1 over cosecant of theta, or cosecant of theta is equal to 1 over sine of theta. And then lastly, we have tangent is equal to 1 over cotangent. Sorry, they should both be theta here. I missed my little theta. And then cotangent of theta is equal to 1 over tangent of theta. So these are going to come in handy as well. And then next, we're also going to show the quotient identities. So tangent of theta is equal to sine of theta over cosine of theta. And cotangent of theta is equal to cosine of theta over sine of theta. Now, if we go back to our original equation right here, we can start plugging things in and doing a little bit of algebraic manipulation. So let's go ahead. Okay, and so first we're going to start with x squared plus y squared is equal to 1. And we're just going to substitute these with cosine and sine. So this is cosine squared of theta plus sine squared of theta is equal to 1. And this is actually one of your identities right here. This is the first Pythagorean identity. Now what we're going to do is we're going to take that and we're going to divide everything by one of those terms. And we're going to start with x squared just because it's the first term. So we take this and we just divide. And so divide by x squared, divide by x squared, and divide by x squared. And so here, this is going to be equal to 1. So this is 1 plus y squared over x squared equals 1 over x squared. And so here, we know that this is going to be tangent, and so this is just tangent squared, because we can pull these squares out. Here, I'll write it all the way out though. So this is 1 plus y over x squared, which is equal to, and then same thing here, you don't really need to do this, but it can help you understand the algebra that you're doing. And so this is going to be tangent, and so we're going to have 1 plus tangent squared theta, and this right here is the reciprocal of cosine, which is secant, and then squared. So secant squared of theta. And this right here is actually another one of your Pythagorean identities. I guess we can go ahead and write like 1, 2. And so, as you can probably guess at this point, what we're going to do for our last one is divide out y squared instead of x squared. So again, we're going to start with x squared plus y squared is equal to 1. And we're going to divide everything by y squared this time. And so here, we can do that same little algebra technique where we can pull out the powers or the exponents. And then this is just the same thing divided by the same thing, which makes it equal to 1. And then here, again, we can pull out the exponent. And we can do this because 1 squared is just equal to 1, right? That's not changing our 1 at all. And here, this is going to be cotangent squared of theta plus 1 is equal to, and here we see 1 over sine, so this is going to be cosecant squared of theta. And so this is really an easy way of remembering all of your Pythagorean identities. Yeah. So if you can remember that we just start with our unit circle equation here, x squared plus y squared is equal to 1. Then we can introduce all of our trigonometric functions here and all their identities, and we can just replace things. Like here, we're just replacing directly, and then here we're going to do a little bit of algebra to get this, and then here, same thing, we're going to do a little bit more of algebra, but starting back from the beginning. And if you can just remember this equation, remember what is equal to what here. So x is equal to cosine and y is equal to sine. If you can remember that, as well as your tangent, cotangent, cosecant, and secant functions, then you can go back through and you can do all of this just from memory. It's an incredibly easy way of doing it, honestly. And I've realized that through all the different ways that I've learned how to do or how to remember my Pythagorean identities, this has to be one of the easiest ways to do it. And so, yeah, these are your 3 identities right here, your 3 Pythagorean identities. And that's pretty much all I have for this video. So let me know if you guys like this style of video. I know it's kind of I'm still trying to get used to writing on here, but let me know if this was a video style that you guys enjoyed, if this was a topic you enjoyed, and what maybe you guys would want to see next. Anyways, thank you so much for watching, and I hope you guys have a great day.